For our next series of topics, what we're going to deal with is a concept called AC power. And in AC power, what we're going to be looking at is what is the relationship between voltage and current in a particular AC circuit. And sort of as a starter example, let's look at this particular resistor here. And imagine that we had put this circuit in our simulator and we want to see a plot of both the voltage and current across the resistor over time. And so, for example, here, let's say that our blue line is our voltage over time. And maybe this had a peak of 5 volts. And then because of the resistor, if it has a peak of 5 volts and our resistor is 1 volt, then we will have 1 amp of current also flowing through at the same time. So as the voltage rises, the current rises. And as the voltage drops, the current drops. And again, let's have our blue line here being voltage and our red line here being our current. What's important about this is that when the voltage is high, the current is high, and when the voltage is low, the current is low. So these two items are in phase. But what can happen in an AC system, in a system that has both resistive and inductive elements in it, is that we've seen with our inductors and capacitors, they don't simply just pass the energy through them. In the particular case of this inductor, there's a little magnetic field that builds up in the inductor, and it actually impedes the flow of current over time. So if we were to draw this same circuit again, and we were to look at our voltages going through this system, they might look like this, but because of the magnetic field in the inductor, and remember that the current through the inductor is the inductance times the change in the voltage, we will actually have some sort of delay in when our peak current will come through. So if red is our current and blue is our voltage, there is actually going to be some time delay between the peak of these two waves. So in our example up here with our resistor, both peaks came along at the same time. Depending on the size of this inductor and all the components that are involved with it, the peak of this voltage wave and the peak of this current wave might actually have some sort of time dependency between them, and they might be off. And this has implications for all the electronics and the motors and the components that we want to drive in this system. So, two major things that we're going to talk about throughout these videos is what is the phase delay, caused between our voltage and current waves, and how do our resistive elements in the circuit, and then how do our inductive elements in the circuit, and this includes both inductors and sort of capacitors, how do they affect the phase of these two waves and when they come through, and the different types of power that are consumed.